Come up, have a seat. Is that looking focused to y'all? Because I have my glasses on.
Yeah, that's good.
Okay, so I'll go ahead and start. So I'm Paul Schreiber from Synthesis Technology, also known as Paul TS on Muffwigler, also was Snarky Guy. I have the Morphine Terrarium is probably my most well-known module I've done in the past. That's been replaced by the Cloud Terrarium, the E352, which won Module of the Year last year for Eurorack, but that's okay. I paid them a lot of money to say that, but it worked out. So I'm going to have a little different tack. So this is not going to be a product presentation per se, except in the last 5 minutes when you have a chance to leave. But if you leave, you miss the raffle. And if you miss the raffle, you miss free stuff, including an E352. Oh, it doesn't work, but you get an E352. So this is a little bit more technical, but it's not real technical. There's no math involved, okay? There's a couple of 4-syllable words involved, but it's going to be what I call helpful Eurorack design tips. And I've already talked to one of the manufacturers in the room. I'm not picking on him personally. I'm picking on other people who aren't here personally. So I come from a family of contract lawyers. So we're going to have lots of helpful tips for design Eurorack modules that do not suck. Now this is a little tip of the hat to my design partner, Scott Ryder, who's also known as Old Crow. You may have heard him on an Old Crow, does a lot of CS80 stuff. And he designed a power supply called a Eurorack power supply that does not suck for his own little internal stuff. And he and I worked on the CS80 filter together and some other stuff. So I kind of stole that from him. But this is going to be a somewhat lighthearted but somewhat serious kind of me on a soapbox, trying to give people who want to be designers or people who are existing designers some things they can do to help the overall Eurorack product experience. I come from a long history of designing consumer electronic products, starting all the way back before everybody in this room was born except for him. Starting with Tandy Radio Shack, designing stuff for them. And people always made fun of Radio Shack, but really we had some pretty good designers in there, and we were pretty strict about things because Radio Shack doesn't want the stuff to come back. Okay, they just want you to buy it, but they don't ever want it to come back. And so I learned a lot of stuff, and it's actually hard to design stuff cheaply. It's easy if you have a budget. I used to design F-22 weapons computers, and the blank board was $30,000 with no parts on it. Okay, and so that's easy to do if you have a $30,000 budget for a board. What's hard to do is design a whole computer for $12. All right, that's hard to do. So, but I've learned a lot of stuff like that, and there's some expectation levels in general when everyone in this room goes and buys a piece of electronic equipment, whether it's a DVD player or a phone or something, you have some expectation level. And what I'm kind of on a soapbox about today is why isn't the same expectation level in Eurorack? Why have we, for some reason, given Eurorack some kind of a pass where if we had that same experience going to Amazon and buying a $29 microwave, you would pitch a fit. All right, but if you buy a $400 module and it acts up, you go, ha-ha, the wild, wild west of Eurorack. All right, so that's what I'm going to try to kind of address. And then we're going to have a little break, and then we're going to have some updates on future products and what I'm going to plan for in the future, and then we're going to have the raffle. And if you have any questions, just let me know because I can talk a long time. So here's my legal disclaimer. All right, I'm going to give some examples. These are examples I randomly found on the web. I tried to obfuscate the people who things I'm using as example. If you recognize anything, please don't shout out and go, hey, isn't that the blah, blah, blah? Okay, you can think it all you want, all right? But let's not name names, okay? So I'm not trying to say this person is bad, and because this person is bad, everything they've ever done, past, present, and future, is also bad, okay? Because some of this stuff is my stuff. So I'm not perfect either, but I'm trying to improve. And that's what we're trying to get here, is the message is, let's do what we can going forward to try to improve the user experience for everybody, okay? Now, I also understand, being in the industry for a long time, that when you make what I call a design decision, it's not as easy as, well, this is the best part. We're going to use this part because it's what? The best part. And I found out, especially in the modular community, you can't say that word, the word best. If you don't believe me, go to Muffwiggler and look at the low impedance busboard discussion about where my partner mistakenly, after I told him not to, said this is the lowest impedance busboard, so it's the best busboard. Okay, that's a trigger word for a lot of people to say the best, because it implies that what? Not that you're the best, but what? Everybody else is what?
The worst.
The worst. Okay. And so I understand that there's a lot of reasons when I say, I think you should do this, and I'm going to say what? And I'll give you all the reasons, and people out there are going to go, okay? But I hope that you listen to my reasoning, and if you kind of believe me, and you want maybe these other manufacturers to maybe take up some hints, maybe you should ask them. Why not? Now, you may get back, well, because Paul said. That's a perfectly legitimate reason. Ask my wife, because she says a lot of stuff. Well, I'm not going to do it. Why? Well, because it's you. But I think I have some explanation. I'll show you why. And we'll just see what happens. So why are things so variable in Euro? So when you buy a microwave oven, for example, you kind of expect all the microwave ovens to operate in the same kind of a way. Which way does the door open when you pull the handle? Where are the hinges? Hinges are on the left, right? You have a cook button. You have a start and a stop. You can do minutes, right? Sometimes there's a button that says popcorn. But that's what you expect, all right? Do you expect to go to a microwave oven and say, I want popcorn? I'm going to hold down these 3 buttons. I'm going to Morse code the word popcorn into the front panel, okay? And I'm going to get popcorn that way. No, you don't. Okay? So I've kind of done some things that I've heard over the years. Now, I've had people tell me all these things more than once, multiple times. These are things. First one is, well, they did it that way. All right? I'll call that the cut and paste reason. In other words, if you're going to say to yourself, I think I'm going to do some more DIY Eurorack kits, and I have a pretty good idea. I have an idea. So I'm going to look around, and I'm going to say, well, here's a circuit, and here's a board, and here's this, and here's that. And I'm not sure about this one section, but they all did it that way, so it must be okay. Right? I can't afford to do it any differently. Right? So I'll say, why don't you use this? They go, well, it costs more. I go, yeah, 12 cents more. Well, it's more. I go, well, make Sean pay. When I say make Sean pay, who am I referring to? Sean and like heaven. I could also say make Jonas pay, but he's a nice guy and he's hosting me, so we won't make him pay. But my point is that the dealers will pay you if it's a good product. Why are you deciding for them before you even give them a chance? Okay. Generally speaking, if it's a good product, $5 at retail isn't going to kill it. I don't know if anybody in this room will say, well, you know, I'd buy that new Quad 370 if it was $5 cheaper. No, you'd buy it if it was half the price, but not $5 cheaper. But you'd be surprised what you can do with $5 at retail. Not even $5 on your BOM, but $5 in retail, you can completely change the user experience of your module for $5 retail. And that means no power cables plugged in backwards, no modules ever blown up, things like that. And I think that most people would say, yep, I sure would have paid $405 not to blow up my $400 module just now. That's my point. It's a false sense of economy. It's easy to say, it's just throw up your hands and say it's more expensive. My personal favorite, this one. Eurorack is a spirited community, and it's the wild, wild west, and yeehaw, and that's part of the allure. And now, I kind of get that when it started 10 years ago, that it was somewhat of a little bit of a secret society kind of a thing where it wasn't mainstream, and people like Roland, you know, weren't making modules. And even when I was doing MOTM kits back in the 90s, there was an expectation level that people, even though I told them 50 times how to put the chip in, they would every once in a while put the chip in backwards. But did they ever blame me? No. But that was kind of part of it. But is that part of your experience when you buy a DVD player? Do you ever, even if you buy a $29 DVD player, do you expect it, if you put the DVD in upside down, it blows the DVD player up? No. If it ever did that, you would have outrage. All right? So why is that expected in Eurorack? Why does Eurorack somehow get this kind of, I'll say, a cultural pass? All right? This is a multi-million-dollar market. Okay? Multi-million-dollar markets shouldn't have things breaking for something that the end user did or didn't do. And then this is the muff wiggler explanation, usually directed at me. Well, bugger off, Paul. Don't bother me with all your double E stuff. Leave me alone. I'm doing fine without you. Leave me alone. What does that make me do? I just poke him even harder sometimes. But, and this is actually a valid thing to tell me. That when I first started MOTM, everybody know what MOTM is? That's my big 5U stuff I did a long time ago. I wanted to use a certain 4-pin power connector. It was big and heavy and chunky, and it was cheap. It's 12 cents. But I wanted to use it just because it looked like it wasn't dinky, and the pins were very hard to bend. So there was no way a user was going to accidentally misplug a cable and bend a pin. And so I started shipping my stuff, and then I had a competitor who was actually at the time local, and he used a different power connector. Smaller pins, different pinout entirely. And so I had a meeting, and I said, look, we need to use the same power connector. And I said, and of course I want to use mine, right? I said, here's why you should use mine. And he says, well, that's all great, but I'm going to stick with mine. And I said, why? The answer was NIH. Who knows what NIH means? Not invented here. Whereas he picked that power connector, so he was going to use it. He wasn't going to pick mine because I already picked it. There was no engineering reason. There was no electrical reason. The only reason was Stubbornness. Right? And I think that stubbornness has a large amount to play in why Eurorack is so diverse. I should know because I'm stubborn. So what I want to do is I want to have a better approach to make the Eurorack experience the same as any other thing. I think it should be no different. Okay. Sir Rupert Neve. When you think of Sir Rupert Neve, do you think of things blowing up? You think of Abbey Road and the Beatles and the sky. He was knighted by the Queen. It's Sir Rupert Neve. Was he knighted because he could plug his power cables in backwards and stuff would blow up on your API consoles? No. Why was he knighted by the Queen? Because it didn't do any of that kind of stuff. People knew that they could buy a Neve mic preamp that was 40 years from the one they bought last week, and what? What did it sound like? Exactly the same as the one they bought 40 years ago. Right? That's what they're paying for. Okay? There's no ambiguity about that kind of stuff. They knew if they took out their 40-year-old Neve mic preamp out of their API lunchbox and plugged in the new one, the power connectors weren't down 4 inches and flipped upside down. They just magically plugged right in. Okay? This is just simple basic engineering. Okay? There's no stubbornness. It's like, why wouldn't you? I mean, why would you go out of your way to do that? Unless you're Yamaha, where you mess up the MIDI standard on the DX7 just because you're Yamaha. Next thing is, and this is what I'm going to probably repeat more than once, is don't be a lemming. I mean, don't add to the problems instead of correct them. And this goes back to the first thing is, but they did it that way. Or, you know what? I've already done it this way for a year now, and if I change, people will notice. I'm like, yeah, they'll notice it's better. But, so there's some reluctance because in my industry, and I've got lots of tales to tell, they're mostly true tales, what I call them. I have seen multi-million-dollar companies with over 5,000 employees go down the drain because one engineer would not stand up and say the 4 words. What? What are the 4 words an engineer will never say usually? I made what? A mistake. That's right. I made a mistake. Sometimes they'll say it only when they're subpoenaed by Congress, like the Volkswagen people. Oh, that firmware. Yeah, we did that. Okay. But I never had that problem. In fact, I'm usually the first to say, boy, I really made that mistake. That was pretty exciting for everybody involved. But people won't make a mistake, and that's what a part of this is. Okay? Having to admit that what you've done in the past is okay, but from this point going forward, there's a better way. There's a better way. You don't have to always go on the path. An example I give is on the computer motherboards, PC motherboards. Apple people just zone out. PC motherboards. What was the first add-in card standard for cards? What was it called? Isobus, right? Modem cards, graphics cards, serial cards, scanner cards, the Isobus. Then they had the what? PCI bus. And they had the Isobus, and they had the PCIe, PCI Express bus, single lane. Then they had the PCI Express 4-lane. How many motherboards were thrown away every time? Tens of millions. Tens of millions of motherboards were thrown away. Billions of dollars in the trash can. 5 times in the computer industry, we literally threw everything away. Everything. I'm looking at you, Eurorack. Think about that for a minute, though. But why did we throw it away 5 times? Why? Because it was better. Thank you. Make things easier on both yourself and the provider and the end customer as a user. Okay? This is kind of back to thinking not about what makes things easy for me as a manufacturer, but what makes the end consumer happier because I did something. All right? And a lot of it comes back to my father's favorite saying, which I'll say later, ink is free. And lastly, especially if you're in the DIY kind of mentality, probably the phrase that I get on SynthDIY Facebook that I don't ever comment, I've never made one single comment, but when I read it, it makes my blood pressure go up. I want you to figure out why it makes my blood pressure go up. So when I read something that says, "Hi, I bought this kit and the BOM says to use a 10K resistor, but I got a 12K resistor left over. What do I do?" Okay. So why does that kind of make me mad? What about that makes me mad? Any ideas? What's generally missing from a DIY kit? The schematic. Because if you had the schematic, you could look and say, well, it may make the LED a little dimmer. It should be fine. Has no effect at all. Probably won't. Okay. But if you keep the schematic a secret, all right, you've done everyone a disservice. Now, you could say, but Paul, if I give you away the schematic, not only do I give away my secret, other people can copy me. And I'm going, that's not going to stop someone with a voltmeter and a pencil and paper, because all they got to do is take that voltmeter and go to every node and every circuit and draw it out. Even if you go so far as to say, I'm going to sand the ink off the tops of the chips, that's not going to stop me either. Why is that? Why does that not stop me?
It's only a handful of chips.
No, because the part number is on the die.
And the part number.
Okay? All it does is make me take out my channel locks and go, ha ha, okay, there it is, thank you. You delayed me by 5 seconds. You slowed me down by 5 seconds. You go, but you broke the chip in half. I go, yeah, your 12-cent op amp I broke in half, I'm sorry. Throw away the cookbook. Instead, learn how to cook. And then you learn how to write the cookbook. Did Julia Childs get famous because she could follow cookbooks? How did she get famous? Because she figured out how to write the cookbook. So in other words, I want the kit vendors as well as the consumers of the kits to kind of have a mindset where I'm not just taking a list of parts and soldering these parts in these holes, and I'm following directions, and then a VCO comes out at the very end if I didn't mess up. All right? Have you learned anything by doing that? You've learned nothing except to follow directions. Okay? But if you just follow directions, that's never going to get you anywhere. Further, knowing about what is it that I just built? What did I just do? And the manufacturers have to help you out by giving you schematics so you can at least start somewhere. So what we're going to talk about are just 3 areas, like you'll probably talk about 42, about how we can improve Eurorack. The first one is my big soapbox about Eurorack power coming and going. When I say coming and going, I mean coming in to your modules, okay? And then what do the modules do once they have the power in there? What happens? Pardon me. Ink is free. Any idea what I mean by that? Just offhand, when I say ink is free, what I'm talking about? Anybody have a guess?
Get it right on the paper so that you don't have to make mistakes.
It's a good answer. It's the wrong one, but it's a good answer. I'll get to it later. products versus design. Okay? I want people to stop shipping Eurorack designs and start shipping more Eurorack products. There is a big difference. I love this picture. This is a great engineering picture. Europower and how it's used. Of all the issues in Eurorack, power is the main problem. Does anybody disagree, by the way? Besides I'm the main problem, the Eurorack power. Don't be shy. Don't be shy. Anybody ever blown something up plugging in wrong?
Yep.
Did you blame yourself?
Oh, totally.
Did you think it should have blown up, no matter how you plugged it?
No. I mean, I have since become extremely infuriated with the situation.
The delayed reaction.
Yeah. So.
Okay. Fixing issues of Eurorack power. All right. Everybody knows what a shrouded header is versus an unshrouded header? Okay. So on Eurorack power, a lot of modules just have rows of pins. You take your little ribbon connector and you plug it on those pins. And what has to happen for it to work? You have to line them perfectly. You can't be off by one, which is like this way or that way, right? You can't come at an angle. What happens if you come in at an angle on those pins? What happens? They bend. They bend. You can bend them. Right? Swing and a miss. Bend, bend, bend. But if you have a shrouded header, which has the plastic around it and the little key, all these problems go away. It's impossible to have an off by one insertion because the walls of the shroud prevent it from being off by one. You'll never have an off by one problem. All right? Unless you really try really hard, you'll never bend a pin on a shrouded header. Now you can sit there and I'll get videos tomorrow on YouTube like, look what I did. But generally speaking, it's quite difficult, let's just say, to bend the pins on a shrouded header. Plus, there's no question about where pin 1 is. All right? In Eurorack, what is pin 1? What is pin 1? Anybody? Minus 12 volts. Right? The red stripe, unless there are a few other manufacturers who went, I don't care. But there's no question about where pin 1 is in the shrouded header. That shrouded header has been in the industry since 1964. And we've never moved pin 1 from 1964. That's always that pin over there. And it's marked on the header. So there's no question about where pin 1 is, which means there's no question about where the red stripe on your cable goes. It ever is. Right? So I've, over the years, been trying to tell people nicely and quietly in my own way, please use shrouded headers and stop using just pins. And here's the reasons they've given me not to. Sorry if I offend some women in the room, but this is just me talking. The drunk girlfriend cable problem, okay? This was because someone once admitted to me that their drunk girlfriend was actually making cables one day, binge watching Game of Thrones, and she happened to flip a few of the headers around backwards and ship them. And I said, well, aren't they tested? No. Why not? Well, we don't have a tester. Of course, my next question is, why are you even making cables? When there's literally hundreds of companies out there whose entire job is to make cables, and they have $50,000 piece of test equipment to make sure every cable is perfectly made. That maybe you can't afford, but they've already got one. In fact, they've got 12 of them. Okay? Why are you making cables at all? Well, the minimum order quantity is 1,000. I don't need 1,000. Well, if you buy these cables overseas, you buy them at 1,000 pieces, how much are they? 40 cents each? Then why don't you throw 500 in the trash can? still cheaper than what you can buy the parts and labor for, and bonus, they're 100% correctly made. Shrouded headers cost more than unshrouded headers. Yes, they do. They cost more. And what's our slogan about when things cost more? What do we say? Make Sean pay. I don't think that charging an extra $1 at retail for a shrouded connector is going to prevent someone from buying your module. It will prevent from plugging the cable in backwards and bending the pins. They take up more PC board room. Yes, they do. About 22% more area. So what does that mean? They'll still fit on your board. Even a 2 HP module will still fit. So here's my conclusion. I say mine. That's what they look like, by the way. So y'all have seen these on boards, I'm sure. There's really no reason I can think of not to use them from a technical standpoint. At all. None. So I encourage everyone, stop trying to rationalize it. Now, I'm sure there's some manufacturers say, well, that's all fine and dandy, but I have, I don't know, I guess if you're saying mutable, 100,000 of them already in stock. I've already bought them. And I say, well, once you use them up, don't buy them again. So that's what they look like, by the way. That's the 10 pin and the 16 pin. And so this is called the key. Now, is it physically possible to flip that cable around and try to plug the little key over here? Can you do it?
If you have a razor blade.
Well, the answer is yes if you try really hard, or some people take X-Acto knives and shave the key off. So it's not completely what we call hard keyed. This is a soft keyed system. But it's still better than just having pins stuck up in the ear. Okay, here's the other half of the equation about using an unshrouded connector and cables that are made wrong. Reverse power protection. And what this means is, even if I made a mistake and I plugged it in wrong, the module should not blow up. It should be tolerant. An example I give is this. Let's say that you bought, that is one hot pipe. I just want you to know. I'm lucky I didn't say anything. Where was I besides dying right there? So if you go to Amazon and you go, tax refund time. Sorry, Jonas, but tax refund time, and we're going to go buy me a new Blu-ray player and a new Sony 4K OLED TV, and I'm out of money, so I want to buy me a monoprice HDMI cable for $4. And you get your DVD player and you get your Sony thing and you hook your little monoprice HDMI cable up and you plug it on and your TV blows up. And the reason it blew up, you've discovered, is you had a monoprice cable where they swapped 2 wires on it. Who are you mad at, Monoprice or Sony? Are you mad at Sony because it blew up, or are you mad at Monoprice because the cable was made backwards? You should be mad at Monoprice. Okay? The cable's wrong. I keep doing that. I'm going to die here in a minute. So, my point is that there should be no bad cables, and we shouldn't have to accept them in the marketplace as something that's okay. Because there are a lot of reasons people tell me is, I don't want to use shrouded headers because I may have a bad cable and I can't put the bad cable backwards on a shrouded thing. And my response is, throw the cable away. Tell the manufacturer you would like a new cable, please. Have any of you ever heard of a HDMI cable wired wrong? I haven't. an Ethernet cable wired wrong? Well, unless they're a flip cable, you don't know it's a flip cable. The answer is no. There is no expectation that you would walk and get the cheapest HDMI cable you could possibly find on eBay for 14 cents with free shipping from Hong Kong packet and expect it to be wired wrong. Okay? But since maybe cables aren't going to go away, and since maybe shrouded headers aren't going to take off, there is a prevention that we can do. And I think every module manufacturer should put it on there. And that's called reverse power protection. Because what I'm saying is, why would a designer want the module to fail because misapplied power? All right? I don't want my stuff to fail because I know ahead of time that I'm going to have this vast amount of stuff out there that's not going to be wired correctly. So what can I do to prevent it? The answer is you have to spend, are you ready for this? How much do you have to spend? 2 diode?
20 cents.
I didn't talk to you buy your parts. That's too much. You have to spend about 14 to 18 cents to fix the problem. Our cost. Okay, 50 cents of retail. If I told you I could prevent every single module ever made from now going forward, it will never blow up by putting that cable in backwards. If the manufacturers would spend less than 20 cents, does that sound unreasonable? It does not to me. It's the easiest fix we can do in all of Eurorack is to put in reverse protection. And there's lots of ways to do it. I'm going to talk about 2 of the ways. There's a really clever third way you have to find out yourself. You can put 2 diodes in series with the 12-volt lines on your system. You can put 2 diodes in parallel from the power supply lines to ground. Same diodes, by the way, just wired differently. I'll tell you why. Then there's other clever ways, using FETs, using PTCs, things like that. Series 10 ohm resistors is not reverse protection. Okay? I don't know what it is, quite frankly. So here is an actual schematic from the 370 IP, not patented. Steal this, please. I'm begging everybody out there, please, thanks. Please, sorry, it's too easy. Steal the schematic. I'm begging you, steal this schematic. Here is the part number for the cheapest shrouded header you can buy that's not on eBay. It's from 3M. That's the part number. Please buy thousands of these. Okay? So there's the connector. There's pin 1, which is -12. All right? David doesn't think he knows all the stuff. What's this part here? Anybody know? What's that part? In general, it's a ferrite bead. So we're going to go through a ferrite bead. Then here's our series diode. Series means they're in line with the signal. Right? That's on the plus line. That's on the minus line. There's the part number. And then here's plus and minus 12 that go into my module with these 2 caps. Okay? What these diodes do is that when you plug 12 volts in here regularly and minus 12 in here, let's do plus 12. It goes through this ferrite bead. It goes through the diode, see the little arrow? Means it goes that way and can't go that way, and goes right to plus 12. But if I flipped it, okay, the current would try to flow this way, but it can't. Okay, see the little bar symbol? That means current, no, go that way. The answer is it does. It's called leakage current. It's picoamps. Don't get picky. This will prevent your modules from blowing up if you plug them backwards. Here's the data sheet. So you want to say, let's get real technical. Why did I pick that particular diode? There's lots of diodes. Notice I said the voltage goes across that diode. Well, diodes aren't ideal. When voltage goes across a diode, there's a drop. There's a loss. So 12 volts goes in, but 12 volts doesn't come out. Okay? A little bit less comes out. How much less? Well, that's why we pick one that says low drop. That's what you want. I don't want to drop a whole bunch of voltage there because it just heats up. I want to drop as little as possible. Well, I'll be dang, there's a diode that the marketing people at ST said, this is a low drop diode. Just what you need. Now, this word here, Schottky, that happens to do with how the diode is made. And Schottky diodes have low drops. So that's kind of like redundant, Department of Redundancy Department. But you can change how you make the Schottky diodes to make them have low drop at low current, which is what we're doing, because in Eurorack we're not sucking more than 2 or 3 amps, hopefully. Okay, you're sucking milliamps. So this particular one is specifically designed to have a very low drop at low current. And here's the part number, and it has 2 different packages. So here's what you look for. So this is the most technical part of the presentation. There will be a test. All right. Here's the current in amps. But we're only going to be concerned with about this much. So this is half an amp. How much is that? So we're going to be down here in the 100 milliamps and less, because that's typically what stuff drops off of plus 12. This is the forward drop. This is how much we lose when we go through the diode. So we're going to take our pinky and we're going to run across here to this line, which is 25 degrees C. We go ping, go down, call it 0.3 something volts. So 12 volts goes in, and say 11 point what comes out? 0.65? The first thing you say is, I thought Eurorack ran on plus minus 12. Now you're telling me it runs on plus minus 11.65? Will it even work? The answer is, depends. So let's talk about the pros and cons of doing that. It's 100% effective. That means it's going to work. It's not like it works half the time or part of the time or some of the time. It's going to work. There's cheap, has slow board area. There's SMT for DIY people who want to do everything in through-hole. There's equivalent low drop through-hole parts, one in 5817, for example, things like that, from many suppliers. So it's we call it a commodity part. It's not something weird and special. They're made by the millions, by 12 different people. So why not do it? That forward drop is going to vary based on the current, right? Because it's a curve, right? So no matter where I put my finger, it's going to vary a little bit. It's also going to vary over temperature. How much will it vary over temperature? 2 millivolts per degree C. So when you buy an electric thermometer and you stick it in your mouth, what you're sticking in your mouth is a diode. And it's measuring what the voltage drop is because it's calibrated to 2 millivolts per degree C. So you're going, well, Paul, that's a great suggestion. So now you're telling me the thing's going to vary and the temperature goes up and down, it's going to vary. Why is that a good thing? It's what we do afterwards that matters. What's the other way? Well, you can take those diodes, instead of putting them in series, you can put them in a connection to ground, what's called reverse biased. So they're off. So if you look at the plus 12, okay, there's no current going through here because it's blocked. Because if I turn that diode around, it'd just go all the way and be a dead short. So these 2 diodes here are in the circuit, and when things are fine over here, it's like they're not even there. Because the minus current's blocked by that and the plus current's blocked by that. The diodes do nothing. They're not changing with temperature. They're not even in the circuit. it's a great idea. They don't drop the voltage. When I flip it around, then these two diodes conduct full on. You have full current going this way and full current going that way. All right? So why would you do this? This was done back when people used fuses in power supply. That design is specifically designed to blow fuses downstream on purpose. Right? Because when you apply the voltage backwards, you plug your cable in backwards, you really don't have 0 volts like you do in a series connection. You have plus and minus 0.6 volts or plus and minus 0.35 volts. You have the drop. It's still voltage applied backwards, but it's a little bit backwards, but it's still backwards. But the main thing is you have the full current going through those diodes, and you have to have something downstream to protect it, or you could possibly damage your power supply. So the original dope for power supplies had inline fuses. And so a lot of people put this design in, including me, on my original modules, because Doper had the only power supply solutions. They had fuses, and I wanted to purposely blow the fuses. That was the solution for that technology. Do you see fuses in power supplies now? No, you don't. So you don't want to use that technology. You want to use something else. Okay, but you want to be able to put some reverse protection in. So series diodes is the best way. Now that's the primary effect of having things backwards. Let's talk about the power supply coming in general. With today's technology, again, it's noisy because it's coming from switchers. It's not coming from a linear supply anymore. It's coming from switch mode, little bricks that you buy, the little power warts, whatever you want to call them. Those are switch mode supplies. They actually take your AC line voltage, rectify it into DC, about 375 volts DC. Then they chop it up into little tiny PWM pulses, and that's what makes the low voltage come out on the other end. They chop it up between 500 kilohertz and 1 megahertz rate. And by doing that chopping, they can't get rid of all that noise, and it comes out of your power supply. That wasn't true when we started with Doper cases, when everything was nice and linear. Right? You can't depend on it to be accurate, and when I say accurate, well, if you looked at an old linear 12-volt supply on a scope, it's pretty much a flat line 12 volts. There'd be a little tiny bit of ripple in the millivolts, thousandths of a volt ripple, but it's pretty stable. You look at it on a switcher, you see 12 volts and you have noise all over it. So any instant in time, it's a different voltage. In fact, it can vary 300 to 400 millivolts, like 0.3 to 0.4 volts in time, depending on where you look. That's what you're feeding your module. Okay? Symmetric, what does that mean? That means, do I have plus 12,0,0,0 and minus 12,0,0,0 in my Eurorack? No. What if I have 11.92 and minus 12.05? Is that reasonable? The answer is yes, but you have to be careful. What does that mean in your design? Because a lot of people automatically assume when they do all their calculations, they go, I got plus and minus 12. When in reality, you hardly ever have plus and minus 12. You have plus and minus something, but it's not exactly plus and minus 12. So I'm going to bring up a random schematic I found on the web that is not indicative of any person, place, or thing, past, present, or future. It's a typical analog VCO. I've circled, it's not the whole schematic, it's just part of it. I've circled 4 things that I consider to be room for improvement. I'm not using the B word, which is best or bad. They're just room for improvement. So y'all can look for a second. Ignore, that's not a line, by the way, that's the door. Okay, here's section 1. Now this is not Eurorack. See, I didn't even pick Eurorack because it says plus minus 15. But let's assume that it says plus minus 12, all right? There's a problem here, there's a problem here, there's a problem up there, there's a problem over there. When I say a problem, I mean it's not optimized for a product. This design works perfectly. If you built this design on a breadboard, it would work exactly the way it was supposed to. But it's not a good product. It's just a good design. Anybody, we'll do the easy one first. Anybody have an idea why I don't like this? Anybody here electrical at all? Besides David. David, what do I don't like about this?
I don't let you share this.
Because I'm using the power supplies directly. What did I say about the power supplies? Were they stable? No. Are they noise? Are they quiet? No.
Right.
Are they symmetrical? No.
You're not going to get stable or predictable tuning or tracking with that because it's never going to be 12 volts, and you're going to have to go in and calibrate it
Right.
with that little trim pod every time to get it accurate.
Okay. This uses the power supply, we call them the rails, like we're riding the rails, directly in our VCO. If these voltages go up and down, what does the pitch do?
Varies.
Goes up and down. I don't want that on my VCO. This one's probably the hardest. What do I don't like about number 2? I'll even point to it. What do I don't like about TLO 74 there?
It's a pretty crappy op amp for that.
Let's not say crappy. Crappy's a bad word.
It's a very inaccurate and unpredictable.
It's not the right op amp for this application. Okay? I know that a lot of people think TLO 72s and TLO 74s, they work everywhere. It's all I've ever seen. I've never built a DIY kit that wasn't TLO 74 and 72. Are there any other op amps even available? Yeah. This is the wrong part to put there. Now, if I build it and I put that part in there, will it work? Yes or no?
Yeah.
Yes, it will. And what's the good phrase about that? It works great for me. It worked great for me. I built it. I don't care what Paul said. I built it, and it worked great for me. I'm not saying it won't, but what I am trying to say, there's a much better part to put there. Number 3, that's a voltage divider coming off that triangle thing. So you have, this is kind of weird to me. Nothing to point with. I'll point with my raffle stick. So here you have an op amp that's going to set the level of the triangle because it's set by these ratio. This is a DC offset. That's the amplitude. Then you come out of here and change the amplitude again after you've already changed the amplitude there, setting the amplitude. You change the amplitude with the voltage divider. And what is the bad thing about having that on the output? What is the output amplitude based on? The load. The more I load it, the amplitude is going to change because it's going to load that 2K resistor down and change the output amplitude based on how many things I put in my stackables up there. If you've already got a level shifter here, why do you have a level shifter there? Oh no. Number 4, the same problem as that one. It's the same problem as that, which is what? What's the problem?
Straight off the rails.
Straight off the rails. There's no reason to ever put anything straight off the rails except, we'll talk about the except. I got so worked up, I need a drink. I don't know why he's laughing. The number one bad design practice I've seen in all of Eurorack is what I call the electronotes cut and paste problem. So first off, to even know what that even means in context, who here knows what electronotes is? When I'm talking about electronodes, anybody? Achoo, shut up. Yes. What is electronodes? You raised your hand. Somebody did. Yes.
I have some idea. I think it was an old mailing list.
Okay, it was a printed magazine, quote unquote, loose leaf, that a guy named Bernie Hutchins did back in the 70s that was how to design synthesizer circuits. He still sells it today. It's by far the best way to learn how to design synthesizers. Not Horowitz and Hill, not Googling stuff off the internet, not listening to me. You buy electronodes. He taught you exactly why is a filter a filter. How can you take a capacitor and make an oscillator out of a capacitor? That's what he taught you. It was a very technical, I'll say freshman level college textbook on the theory of how to design synthesizer circuits, which means it's not what?
Products.
How to design synthesizer products. It's still the best way to learn design. However, it is not the best way to learn about a product. I'm just going to put my face on here and get it over with. I'm like a moth. There's a light and there's heat. If electronotes is the best way to learn the theory of design, in general, what would be a good place to look at to learn how to design a good product? Anybody? What thing? Name it as a thing. The last word is manual. The service manual, right? If I buy a service manual of a TR-808 or a TB-303 or a DX7, because it's a service manual, what does that actually mean? They built them. They put them in the field. You bought them for many years. So what is going to be in that schematic, in the service manual, that's not in something like electronodes or random schematic I Googled off the web? What's the difference?
It's a finished product.
It's a finished product, and it's got stuff in there that has nothing at all. Repeat. There are things in there that has nothing at all to do with what it sounds like or what it does. If you take the things out, it will still work. So why are they in there? So it won't blow up. If you walk up across the carpet in your little socks with a patch cord and you go, gzz, don't ESD it, it won't blow up. Right? If you short the outputs together, it won't blow up. If you plug the MIDI cable in wrong, it won't blow up. If you have a miswired MIDI cable, it won't blow up. Okay, it's a product because there's stuff in there that's added to prevent the average consumer from damaging the unit, but doesn't affect the sound at all. That's where you learn. So I encourage people, stop just Googling stuff off the web, get service manuals, and look and see what they did. And I'm talking about even synthesizer manuals. You can learn a lot from old Sony and Panasonic CD players and stereos. There's a lot of interesting things in there that you may have never thought of, but they're in there. And that's the difference between design and a product. You have to remember, Bernie was teaching the basic principles and not go off and build these. Okay? Because what he has is what he built in a laboratory on a bench with a nice, pretty power supply. And how many did Bernie build before he published it a schematic? How many did Bernie build? 50? 20? One? One? So, would you be real confident if you walked up and said, man, that's a great new synthesizer, I saw it in the Waldorf Super Whiz Bang Cotuano, it's $5,000, it's got OLEDs and sliders and it samples and it's 57 polyphonic and the guy says, yeah, we built this one here and then we're going to start making them. You'd go, I don't think so. All right? You expect people to build more than one and decide. When you get a service manual, you're looking at tens of thousands of things that they've built this way. We're almost done, by the way. All right, so this is what I talked about the CV summer on that first schematic. The things in yellow I highlighted. I'm going to go over with. I've already said the answer, but directly using the power supplies, wrong part. Why do I have a trouble with that 3.3 megohm resistor there on the fine tuning? So here's a trick question. If you ever meet a double E, he's maybe in the bottom half of his class and want to pay attention, you want to win a bet, $5 bet, say, I bet you can't name me a way to measure the value of a resistor without putting any current through it. The answer is you put it on a true RMS AC voltmeter and you measure the thermal noise. You can calculate the resistance based on the RMS amplitude of the noise because it's directly a function of the value in the temperature. There's no current going through it. You don't want to have many megohm resistors sitting here because chances are, where is this on the module? This fine tuning thing, where is it? It's on the front panel. And where is that resistor going to be? On the board. And how long is that trace going to be, maybe? So you don't know. This is a very high impedance thing. In fact, that's so high impedance that you can get AM radio going through there through the ESD diode rectification. You can pick up AM radio. You start going above 3 to 4 megohms, like that. This is right out of Electronotes. Someone can say, why is it so big? Well, because he has 30 volts across here. And when you do fine tuning, if a 1 volt per octave, and you say, well, I just want to tune one note, I want a 1/12 of a volt. So I'm going to start with 30 volts over here and try to get a 1/12 of a volt coming out of here. So you have to divide by this huge ratio and you wind up with these giant resistors. So what's the easiest way not to do that?
Just send it a volt.
I mean,
Each, 1 volt each.
you put 1 volt here and here, and then you only have to divide it by 4 and you're done. The question is, where do you get the volt? It's not on the back plane of Eurorack. Well, we make it. We have to spend money. So this is the whole thing about that schematic. Again, my favorite saying, it works great for me. Power supplies track each other, that's wrong. TLS74 is not the right part. We'll talk about why. Think about why it's not the right part. I've already told you it's not the right part. Now, unless you know electronics, you may have no idea, but that's fine. But think about VCOs. If you're in a VCO, you don't want your pitch to drift. The power supply is summed in. The fine control is a bad design because the resistor's too big. Please steal this schematic. This is the summer on the E370 quad VCO. I want you to steal this schematic and use it everywhere. You can just PayPal me later. I use plus and minus 2.5 volts internally for all my controls. All the controls I use only swing plus and minus 2.5 volts. Not plus and minus 15, not plus and minus 12, plus and minus 2.5. Why? What does it make? The resistor is small, 29K. I went from 3.3 meg in Bernie's design to a 29K in my design. I automatically have 100 times lower noise than he has. Okay. The other thing is, do you really have to go between plus and minus? No, for some things you can just go to ground. Bernie did everything plus and minus because this was easy for him to do. But if you start thinking about things, sometimes you don't really need to have plus and minus. You can only go plus or only go minus. You don't have to go plus and minus. Like here. So now I have all small values. My biggest value is 392K, not too big. I added that. I put a capacitor across the feedback resistor. You'll never see this in electronotes because that's a product decision, not a design decision. Any idea what that capacitor is doing there? Why I put it in there at all? Why I spent 2.5 cents just because I love you guys and gals? It's a noise filter. So if any noise comes in here, I get basically a free low-pass filter here to get rid of the noise going downstream by adding this one capacitor. Costs 1.2 cents. But I can filter out a lot of power supply noise with that 1.2 cents. And lastly, super whiz-bang, fancy schmancy analog devices op-amp that doesn't cost 25 cents. No, boys and girls, it costs $1.85. What am I thinking? Well, I'm not bankrupt yet because I bought it. That's what I'm thinking. What I am thinking is that thing's not going to move over temperature or power supply because this is the right op-amp in that application. Not a TL74, not a TL72, not a 741 just because I want to be vintage. That's the right op-amp.
Are you able to get rid of the Temco resistors and still have?
I have a DSP. What's that? Yeah. All right, so let's talk about what I did. I made my own plus and minus 2.5 volt power supplies. So I took the 12 volt supplies and internally I used parts to make 2.5 volts. Not only that, they're tracking. So if the 2.5 volts is really 2.478, the minus supply is minus 2.478. They track up and down. How did I do that? The exercise is left to the reader. If I can do it, you can do it. Fine-tune reference to one supply line drops your value by half, 50% automatically. Okay, I just have to tune it. I don't have to go negative from where the tune is. I can just tune it. Here's the op-amp I used. It's called an 8606. If you want an old school through-hole dip part, it's called an LT1013. I used the LT1013 from Linear Tech and the MOTM 300 and 310 VCOs. It's specifically designed for thermocouple amplifiers, which has very low temperature drift, and that's the answer we need. Is I want, in that application, I want low temperature drift, and guess what? Op-amps have temperature drift. So why not put one in there that in the data sheet, wait for it, what does the data sheet say? Low temperature drift. That's what we want. And if you don't believe me, here's the data sheet. So, but everyone uses TL74. Not moi. What we're looking for is offset voltage drift. This means over temperature, what does the output change just by the op-amp itself? Not what's coming in or going out, but the op-amp itself is adding an error. How much error does that op-amp generate all by itself as the temperature changes? This one's a maximum of 6 microvolts per degree C. How much is a microvolt? A microvolt is what? A millionth of a volt. I think that's low drift. 6 millionths of a volt. How many volts does it take to change one whole step on a 1 volt per octave system? It takes 83 millivolts, 0.083 volts. So this is 10,000 times less than 1 note drift. That's low drift. If I were to pull up the data sheet for a TLO74 and say, okay, Paul, that's so low, I can use a bigger drift and still not hear it. That's a correct answer. There's one problem I have with that. What does it say? It's not even in the TLO74 data sheet. It's not spec'd. It's not tested. You could have a part that you wave your hand over and it looks like a theremin, and they would ship it because what we say in the industry, that is not characterized. There is absolutely no guarantee what that drift is. Now, is it possible to buy one? And it's lower drift than that? Yes, it is. Because just because it's not characterized doesn't mean it's worse than that. It could mean it's better than that. But what does logic and marketing tell you? If it was better, we'd sell it and get more for it. Why does an TLO74 cost 28 cents? Because it doesn't test that kind of stuff. Remember I said there's one reason, or there's one thing we can hook right on the power supply rails without too much worry? That's op-amps. Why? Because even bad ones have what's called high power supply rejection ratio, which is abbreviated PSRR. What that means is if I have an op-amp and I tie it so the output is ground, there's no input and no output, it's ground. And I take the power supply and I just vary the voltage up and down as fast as I want to, or as much as I want. What should the output do? Shouldn't change, right? You don't want your output to change on the power supply. That's what they call the rejection ratio. Okay, it's measured in dBs. A dB is a lot, 100,000 factor. So this particular op-amp has 10 times more power supply rejection ratio than TLO74. So this op-amp not only will reject noise from the power supply more than a TLO74, it certainly won't drift. It's guaranteed. That's the difference. This part is guaranteed not to drift. The TLO74 is guaranteed you don't know. That's the technical part. Now we're on the home stretch. You don't even tell what that is. Looks like one of those conspiracy YouTube videos about there's a moon base. Ink is free. All I'm telling you is you're sitting there and you're trying to get the board out. You're anxious. And you think, and it's all designed, and it's all hooked up, and it's working. Spend 5 minutes. 5 minutes. To put some ink on the board, which costs you nothing, but really makes the end users happy. Why do I think this is a bad idea besides it's fuzzy? So this is a Eurorack power connector, shrouded or unshrouded? Okay. See that one? What is that? There's a 1 there. This says SV1. So this pin has a 1. This pin has SV1, and this pin over here has a 10. The cable fell off. Where does the cable go? Is it possible to put the cable on wrong?
Almost certainly.
Okay, now, where's pin 1? This says SV1, this says 1. Which one is 1? They both say 1. Well, it turns out that, what does SV1 mean? That's the part number, the reference designator for that connector. Well, why would you just put it over here? All right? If pin 1 is minus 12, and that's where the red stripe goes, what would be a really cool thing to put right here?
Red stripe.
How about a line or red stripe or minus 12 volts
All of those things.
or something? Let's look at some more examples I randomly found off the web that don't imply anything to anybody. Here we go again. Now SV1 is over there. That's something you're going to see when you look at modules. Is you're going to see, wait a minute, I bought these two modules. It says SV1 here and SV1 over there. They're different. This one is moved over some, because it used to be over there, now it's over here. It's almost like it could be almost in between. It's closer to that one, so that must be pin 1. I think more ink is needed here. Now here's a slightly improved version. Here's a shrouded header with a plus randomly stuck over here and a minus over here like it's a battery. You're supposed to put a battery there or something? I don't know. It's plus and minus. Plus and minus what? Whatever, right? So could that module work off a plus minus 9? Like if I take two 9-volt batteries, could it possibly run?
Maybe.
Doesn't say plus minus 12, does it? It says plus minus. I could use a battery, because my battery, the first thing you learn as a double E is that batteries that say plus and minus, that's not minus. That's happy your grandmother minus. That's not negative voltage. Okay? I think this needs more ink. I think it could say red stripe minus 12. It's built correctly, by the way. This is pin 1, by the way. How about this one? Does this get the award? It gets the award. Look at that. Plus 12, ground, minus 12, red stripe. Let's drink beer. This guy gets 100. He gets 100. It's an Erica Sense module. He gets 100. That's all I want to say about Erica Sense. But he gets 100 for this. Is this so hard to do? Is it? No. People say, look at all that room. Look at all that room. I don't have room on my board. What do I say? Make room on your board. Move the connector, move a part, move something. Because generally, what you have coming in, well, this is so fuzzy. These little black things, what do you think those are?
Diodes.
Protection diodes, correct. What are those? Caps. If I move, do you see these caps over here anywhere? Why? Because it's not critical. They can be a half an inch away and still work perfectly good to allow you to have that ink on the board so there's no question. This is free. Now I'm foaming at the mouth. I think we have 2 more slides before a break. Designs versus products. I'm trying to say design. It works great on my prototype. I built one on my bench. Maybe I made 2. I made one for my buddy, made him pay for it. And how did you test it? I'll say, well, I've got this really nice power supply I bought off of eBay. It's, some Rygel. It costs $300. It has really good ripple and specs. But that's not what's in here. So there was a famous line of products from sequential circuits, and they all had power supply problems. And so did Oberheim, because those two guys were electrical engineer designers. When they designed their prototypes and built them, what power supply did they use to test them? And the nice Hewlett-Packard ones on their bench that cost $1,200. But you don't ship $1,200 power supplies in your synthesizer. You build some little weird crappy thing and hope it works, and then it doesn't work. And they had problems for years and years and years, because power supply design is hard and it's boring. But you have to get it right, because if you don't get it right, nothing else works. A product, you take everything bad into account, like ESD. In other words, you have a working design, but then you look at it and you say, what are the 55 things that people could do wrong, or the parts fail, or if in DIY they put stuff in wrong, even though I told them not to, they did it anyway. You check it over many units, and then you say, and this is true on every module I've made in Eurorack except the E440 filter, but everything else I've ever done, speaking just for me, 9 to 12 volts, I don't care. In fact, it's 9 to 15 volts, I don't care. You can run my supplies off of plus and minus 11, plus and minus 14, plus and minus 13, plus and minus 9.426. It's independent of the supply voltage. Not just the noise of the supply voltage, but it's independent, because you don't depend on that voltage at all. This is the last question. We're going to have a break. Raise your hand if you think this is a product. I'm not saying anything about this design, except in my opinion, this is a design and it's not a product. And it's not for the reason you think. It's not because there's multiple boards stacked up with no mechanical support. It's not because there's tail-end capacitors, which you should never use in a million years. It's not because this wire, which is a piece of ribbon cable, stripped and soldered in 3 places because he wants a common connection. The problem I have with this board are those trim pots. Not because there's 12 of them, but because why? What's the problem I have with those trim pots? Exactly. Well, you can reach that one on the top. And you can probably reach these if you reach in there and turn them. Now, why they're sticking off the board, I have no idea. But you know, they do make trim pots that have side adjustments. Just saying. Okay, so the things I didn't talk about before I take a break. Well, I did talk about the user interface. I'm not going to pick on anybody just because you have to hold down 5 buttons. Look at the color LED, count the number of blinks in 12 seconds, then try to stick a modem file through the port to update the firmware. Think about the user interface. I know a lot of tendency is to try to make modules as small as possible, like 2 HP. So you have to give something up to do that. But you reach a point of diminishing returns where people are going to say, if you were just 2 HP bigger, I didn't have to do that, I'd be a lot happier. The unboxing experience, and listen, I'm as guilty as the next person about the manuals, but at least have something in there, not a piece of paper that says, go to the website, I hope I have a manual there by the time you read this. I call them quick start guides. Make the experience. Now, we don't have to go like in a consumer thing where, well, there's one company, Roland, that if you bought a Roland Eurorack module, you got a piece of paper about this big, 12 languages, you know. Maybe not that extreme. Easy to upgrade firmware. There's ways to do it. It's a lot easy. If you want easy, come talk to me and I'll show you how you can update my firmware in 30 seconds without anything except a micro SD card. There's lots more, but that's it for right now. So we're just going to take about a 5-minute break. There's a restroom right behind the store over there. There's some drinks in the back. If you don't have a raffle ticket, come get one. And I'll see you in 5 minutes.